Hello students, welcome back to the lecture series of Mechanical Properties of Fluids. This is lecture 7 and today we are going to understand angle of contact. Okay, so before understanding angle of contact, we need to make an observation first, which is about the top surface of the liquid whenever it is filled in a tube. So let's say we have a tube over here and we fill a liquid in it. Now we generally expect that the top surface of the liquid should be flat, but that is not necessary. The top surface is curved. Now, it can be curved downwards like this, or it can be curved upwards like this. This curved shape is called as meniscus. Okay, so whenever we fill the liquid in a tube, it is not necessary that the top surface of the fluid will always be flat. It can be curved downwards or it can be curved upwards, and this shape is called as meniscus. Now, the shape of this meniscus, whether it is flat or it is curved upwards or it is curved downwards, it depends on the angle of contact. So let's understand this angle of contact. We'll read the definition first. The angle of contact denoted by theta between a liquid and a solid surface is defined as angle between the tangent drawn to the free surface of liquid and the surface of the solid at the point of contact measured inside the liquid. Okay, so let's understand this definition with an example. Now on the left hand side, I have a tube in which the top surface of the liquid is curved downwards. Such a meniscus is called as concave meniscus, and we have shown the angle of contact. So let's understand that angle of contact. So the top surface is curved like this. Therefore, this is the tangent drawn to the liquid surface, and we can draw a vertical tangent to the solid surface. The angle between these two tangents, theta, is nothing but the angle of contact. And we can see that for a concave meniscus, the angle of contact is acute. Let's see the angle of contact for a convex meniscus. Now, in this meniscus, the liquid is curved upwards like this. Therefore, we have a tangent drawn to the liquid surface like this, and a tangent to the solid surface will again be vertical. If we measure the angle between these two tangents, this angle, it is given as theta. Now, we can see clearly that for a concave meniscus, the angle of contact is acute, and for convex meniscus, the angle of contact is obtuse. And both the angle of contacts, we have measured them within the liquid. So, to measure the angle of contact, we first draw tangents to both the liquid surface as well as solid surface. After drawing the tangents, we measure the angle between the tangents while keeping in mind that the angle should always be measured within the liquid. Once we get this angle, that angle is nothing but angle of contact. Now let's study another case where the liquid surface at the top is flat. So this is the flat liquid surface. Now let's see what is the angle of contact for such a liquid surface. First we draw the tangent to the liquid surface, then we draw the tangent to the solid surface, and then we measure the angle within the liquid. Now within the liquid, we can see that the angle between the two tangents is 90 degree, and therefore we can clearly say that for a flat surface, for a flat liquid surface, the angle of contact theta is 90 degrees. So what we have seen is, if we have a concave meniscus, the angle of contact is going to be acute. If we have a convex meniscus, the angle of contact is going to be obtuse. And if we have a flat liquid surface, the angle of contact is going to be 90 degrees. So we just saw what is angle of contact, and we also saw that the angle of contact is acute for a concave meniscus and it is obtuse for convex meniscus, whereas it is 90 degree for flat surface. Now we have to understand the formation of different meniscus. The first meniscus whose formation we are going to understand is a concave meniscus for which the angle of contact is acute. Now, the formation of the shape of meniscus, concave or convex, depends upon the relation between adhesive forces and the cohesive forces experienced by the molecules of the liquid which are near the point of contact. So let's understand concave meniscus based on that. So over here in the diagram on the left hand side, we have an adhesive force acting on the liquid particles which is towards left, and it is inside the solid. Then we have a cohesive force AC which acts inside the liquid at an angle of 45 degree with the solid surface as well as the liquid surface. Now, for formation of the concave meniscus, the liquid must climb like this over the solid, which means the liquid must be attracted towards the solid. And therefore, we consider in such cases that the magnitude of adhesive forces must be greater than the cohesive forces. So we consider that the magnitude of adhesive force is so large such that the net force, this net force AR, it is directed inside the solid. Now, we need to remember this as a condition that for equilibrium of liquid surface, the net force AR, which I have darkened over here, this AR, must be normal to the liquid surface. Now, initially, the liquid surface is flat. Initially, this liquid surface is flat. And this is the force AR. This is the force AR. Now, if we draw a tangent to the liquid surface, the force AR is not perpendicular to this tangent. But the requirement for equilibrium says that the net force must be normal to the liquid surface. And for this to happen, what the liquid surface does is that it climbs over the solid. It climbs over the solid like this. And when the liquid starts to climb over the solid, at a certain point, what happens is this force AR becomes perpendicular to the liquid surface, and we say at that point the equilibrium is achieved. So for resultant force AR to be normal, which is the requirement for equilibrium, the liquid piles up against the solid boundary, which means that the liquid climbs up over the solid so that the tangent AT, this tangent AT, I have darkened it over here in the top diagram, the tangent AT to the liquid surface becomes perpendicular to AR. And because of this, we get a concave meniscus. So the final points that we need to remember for formation of concave meniscus are that your adhesive force should be greater than your cohesive force. The net force must be within solid, and the net force must be perpendicular to liquid surface for equilibrium. And for this to happen, the liquid piles up against solid to form concave meniscus. Okay, so we just saw the formation of concave meniscus by understanding the relation between the adhesive force AP and the cohesive force AC. Now, let us understand the formation of convex meniscus. So, in convex meniscus, the liquid is curved upwards like this. Now, since the adhesive force was greater in the formation of concave meniscus, here in the formation of convex meniscus, the adhesive force is smaller than the cohesive force. So, let's see the forces. We have an adhesive force AP, which is horizontal. So, this is the adhesive force AP, which is horizontal. Then, we have a cohesive force, which is very large. So, the cohesive force is very large. It is AC over here, like this. And obviously, that AC force is making an angle of 45 degree with the solid surface as well as the liquid surface. Now, since the cohesive force is very large, the net force AR is directed inside the liquid. While formation of concave meniscus, the net force AR was directed inside the solid. Over here, in the formation of convex meniscus, the net force AR is directed inside the liquid. Okay, so we saw the condition for equilibrium in concave meniscus. The same equilibrium condition is used in convex meniscus, which is for equilibrium of liquid surface, the net force AR must be normal to the liquid surface. So initially, the liquid surface is flat and AR is directed like this. Therefore, the net force AR is not perpendicular to the liquid surface. Now we have to make this AR perpendicular to the liquid surface. So for that, what happens is the liquid surface creeps down the solid. It creeps down the solid up till the point where the tangent to the liquid surface becomes normal to the net force AR. And at this point, the equilibrium is achieved. So the liquid near the wall creeps inside against the solid boundary to achieve equilibrium, and the meniscus in such case is convex meniscus. So we can see that when the convex meniscus is formed, the tangent AT has become perpendicular to the net force AR. So this is how a convex meniscus is formed. So the important points that we need to remember for convex meniscus is the cohesive force now should be greater than the adhesive force. Then the net force AR must be within liquid. The equilibrium condition is same, and over here the liquid does not climb up on the solid surface. The liquid creeps down the solid surface. Okay, so we are done with concave meniscus and convex meniscus. Now let us understand a special case, which is zero angle of contact. Let us first see the conditions which make the angle of contact zero. So as usual, we have the adhesive force horizontal. Here, the number of liquid molecules near the point of contact, they are very less. They are very less. And we know that the cohesive force depends upon the number density of molecules. Therefore, since the molecules are less in number, the cohesive force is also less. It is almost negligible. And therefore, we write AC equal to 0. Now, since cohesive force is 0, the net force AR must be equal to adhesive force AP. Therefore, we have AR is equal to AP. Therefore, the resultant force or the net force AR is horizontal into the solid. Now, we know for equilibrium, AR must be perpendicular to the liquid surface. For this to happen, the liquid surface climbs vertically. The liquid surface climbs vertically up the solid. Okay. Now what has happened is the solid surface is already vertical, the liquid surface is already vertical. Therefore, the tangents to the solid surface as well as liquid surface, they both are also vertical, and therefore the angle between the tangents is now 0 degree. So since liquid as well as solid surface both are vertical, both are vertical, therefore, the angle of contact theta is now 0 degrees. The angle of contact theta is now 0 degrees. So, this is the case of zero angle of contact, which occurs when the cohesive force at the point of contact is 0. Okay, so let's move towards the last case of the angle of contact, which is an angle of contact equal to 90 degrees. And we have already seen that when the angle of contact is 90 degree, the shape of the meniscus, which is the top surface, is flat. So let's see what are the conditions. So from the diagram, we can see that the adhesive force AP is again horizontal within the solid. The cohesive force AC is inside the liquid at an angle of 45 degree to both solid surface as well as liquid surface. Now, we know that for an angle of contact of 90 degree, the surface has to be horizontal. I'll use another color. So the liquid surface has to be horizontal, and if we consider the equilibrium condition, the net force AR must be perpendicular to the liquid surface for the system to achieve equilibrium. Therefore, we can see that from the above mentioned conditions, the net force AR must be along the solid surface. So I have highlighted the force, net force AR, and the net force AR is along the solid surface. Now, for this net force AR to be along the solid surface, if we do simple vector summation calculations, we require that the adhesive force AP must be equal to AC by root 2. The adhesive force AP must be equal to AC by root 2. Now, when this condition occurs, that is, when AP is equal to AC by root 2, the net force AR is along the solid surface. The net force AR is along the solid surface, and when the net force is along the solid surface, the angle of contact that we get is 90 degrees. From this, we can also find out the relation between AP and AC for concave and convex meniscus. So we know that for concave meniscus, the AR should be shifted towards the solid surface, and for that to occur, the force AP must be now greater than AC by root 2. But for convex meniscus, we know that the net force AR is inside the liquid, and for this to occur, the condition is the adhesive force AP must be less than AC by root 2, where AC is nothing but the cohesive force. So these conditions or these relations between AP and AC, where AP is greater than AC by root 2 for concave meniscus and AP is less than AC by root 2 for convex meniscus, we call these conditions as conditions of concavity and conditions of convexity. So what does this condition of concavity and convexity tells us? That when AP, which is adhesive force, is greater than AC by root 2, where AC is cohesive force, the meniscus is concave and the angle of contact is acute. On the other hand, when the adhesive force AP is less than AC by root 2, the meniscus is convex and the angle of contact is obtuse. So we end the lecture over here. See you in the next lecture. Till then, keep studying. Have a good day.